So in this particular video, we will be looking at how to find out the remainders, and there are a few methods for finding the remainders in different cases. So we will look at how to do it. Now, remainder basically means what is left after doing the division. So for example, you are doing 32 divided by 5. Now, 5 6 are 30. We know that, right? 30. So 32 minus 32. So this is the remainder. This is the dividend. This is the divisor. And this is the quotient. Okay. So now let us look at how to find the remainders for some specific cases. So see, the first and foremost case is the pattern method, wherein it is easier to find out the pattern directly looking at the question. So let us say we have a question of finding the remainder of 5 to the power 29 divided by 3. So we have to find its remainder. So here this is odd and not a multiple of 3, right? The base. So we can try to find out the pattern as when 5 is divided by 3, the remainder is 2. When 25 is divided by 3, which is 5 square, the remainder is 1. When 125 is divided by 3, so 125 is 41 into 3, which is 123 plus 2. So when this division is done, the remainder is 2. Then the remainder will be 1 and so on and so forth. So 2, 1, 2, 1 is the pattern being followed here. So we can clearly see that the exponent is odd. So we will directly comment that the remainder is equal to 2. So this is how you can solve the questions using the pattern method, wherein it is easier to find out the pattern in some of the cases. Now, let us look at the second method of solving the questions, which is the remainder theorem. Now, the remainder theorem says that for any function f of x, when it is divided by x minus a, the remainder will be f of a. Okay. So this will be the remainder. So it is generally called as a remainder when f of x is divided by x minus a is equal to f of a. So for example, let us say we have to find 2 to the power 523 divided by 7. Now, can you spot some pattern over here? Rather, let us say 525. Okay, for making our calculations easier. So 2 to the power 525 divided by 7. So it is equal to 2 to the power 525 divided by 2 to the power 3 minus 1. Now, let us say x is equal to 2 to the power 3. So here we can say that this is equivalent to x to the power, see 5 plus 2, 7, 7 plus 5, 12. So it is a multiple of 3. So the remainder will be, so it will be equal to x minus 1 and 525 divided by 3. So it is equal to 1. Then 17 3s are 51. So 175. Okay. Now remainder when f of x is divided by x minus a is equal to f of a. So it is equal to 1 to the power 175, which is equal to 1. Okay. So this is how you can do the finding of the remainder using the remainder theorem. And yes, the statement also says that when f of x divided by x minus a, the remainder is f of a. So this is how you can use this method for solving some questions. Now, there is a special case. So when a number is divided by the number of form 10 to the power n minus 1, which is of the form 999 dot dot dot. So all nines are in the division and there is a to the power k, something in the numerator. So it can be a to the power k or simply a only. So what you do here is you start making the sets of n consecutive digits starting from right to left in A. So for example, let us take 327 dot 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 divided by 10 to the power 3 minus 1, which is 999. Okay. So what you will simply do is you will make the sets 3 to 7, then 3 to 7, 3 to 7, right? There will be 100 such sets. Then what you will simply do is you will write the summation of all this. Now summation will be equal to 327 into 100 and you denote it as Sn. Okay. So summation of all these 100 sets. And remainder of this is equal to remainder of Sn divided by Dn. Now Sn is equal to 32700 divided by 999. So it has reduced to a much smaller number and you can do the solution. So 999 into 32. So 999, 32. So what is it? 2 nines are 8, 1 carried, 3 nines are 27. Sorry, 2 nines are 18, 1 9. Then 2 nines are 18, 1998. And it is added to 29970. So the summation will be equal to 0 plus 8, 8, 9 plus 7, 16, 1 carried. Then 1 plus 9, 10, 10 plus 9, 19, 9, 1 carried, 9 plus 1. Okay, rather 29 plus 1, 30 plus 1, 31, 31968. So 32700 minus 31968. So the remainder will be equal to 732 will be the remainder of this question. So this is how you can do the solution over here. Now there is another special case. We have seen for 10 to the power n minus 1. Now we will see for 10 to the power n plus 1. Now here the method changes slightly. So let us say the number is 327, the same number 327 . up to 300 digits divided by 1001. Now, what we simply do is we do the summation of alternate groups. So the groups here are 3 to 7, 3 to 7, 3 to 7, and so on. Right, 100 such groups. Now summation of alternate groups, which is the first and the third, second and fourth, and so on. Since there are a total of 100 groups, which is an even number, so the summation of S1 of n is equal to 327 into 50. Then S2 of n is equal to 327 into 50. Now, the remainder of this is equal to remainder of this minus this. So S1 of n minus S2 of n divided by dn. So since the numbers are equal, summation will be 0 and the remainder will also be 0 here. So for such questions, you can use this particular method for solving it. Then there is one more thing, which is the Fermat's Little theorem. Now this theorem is applicable when the divisor is a prime number and the HCF of the base and the divisor is 1. So a to the power p minus 1 is a multiple of p. In that case, a to the power p minus 1 minus 1. Okay, so here there will be one more minus 1. So for example, 26 to the power 59 divided by 28. Okay. No, let us say it is divided by 29. And we have to find this remainder. Okay. So the remainder here will be equal to 29 is a prime number and its HCF with 26 is also 1. So we can write it as 26 to the power 2 into 28 plus 3 divided by 29. So it is equal to 26 to the power 2 into 28 divided by 29 into 26 cube divided by 29. Now, this will be equal to 1 into 26 cube by 29 and its remainder. So you need to find out this value only and you will get your required answer. So this is how this particular theorem is used. Now let us look at some CAT 2024 questions which were asked based on this theorem. So 10 to the power 100 divided by 7 and we have to find the remainder. So 7 is a prime number and its HCF with 10 is also 1. So we can say that 10 to the power 100 by 7 is equal to 10 to the power 14 sevens are 98. 98 by 7 into 10 to the power 2 by 7. Now 10 to the power 98 by 7, remainder will be 1. Okay, so it is 7. So 12 8s are 96. So here it will be 96 and 10 to the power 4 by 7. And 10 to the power 96 by 7 will have a remainder of 1 into remainder of 1000 divided by 7. Now see, 14 into 7 is equal to 98. So 140 into 7 is equal to 980, and 980 plus 21 is equal to 1001, right? So this remainder will be equal to 6. So the answer is equal to 6. So this is how you can use this one. And now another question, 10 to the power 68 divided by 30. So again a prime number and again a number of this form wherein HCF of base and the divisor is 1. So we will simply do 10 to the power 68 by 13 is equal to 10 to the power 16 by 13 into 10 to the power 8 by 30. So here this will be equal to 1, this remainder. And for 10 to the power 8 by 13, you can just put it down in the calculator that you'll get in the exam screen. And here the decimal will be 0.69 something, and 0.69 into 13 is equal to 8.97. So remainder is equal to not 8 but 9. You have to take the closest number. So this is how you can use the Fermat's little theorem for solving the questions here. Now we will look at some rules of divisibility for a to the power n minus b to the power n and a to the power n plus b to the power n. Now, a to the power n minus b to the power n is divisible by a minus b. Okay. Now, when n is odd, then divisible by a plus b. And if, okay, so when n is even rather, and if n is odd, then divisible by a plus b only if a plus b is a factor of 2b to the power n. Okay, so a plus b has to be a factor of this for a to the power n minus b to the power n to be divisible by a plus b in case n is odd. And now there are four different cases for a to the power n plus b to the power n when n is odd. Then divisible by a plus b. When n is odd, then divisible by a minus b if a minus b is factor of 2b to the power n. And we are considering a to be greater than b here, so that this value is also positive. Okay. And if n is even, then it is divisible by a plus b when a plus b is factor of 2b to the power n. So that is pretty much it from this particular video. And in the next video, we will be looking at the meaning of factorial and what are its implications.